This is the sixth of 6 videos on a lab introducing basic motor usage, modeling, how to use the motor, how to make measurements, and how to create a torque speed curve. And just want to take some time here to review a few things that I hope you'll take away from studying in this lab. By the time you're done, I hope you'll have learned how to run the basic motor if you have never done that before, how to measure shaft speed with an encoder, using Arduino to do that. Also, you'll have taken some data so that you can construct a torque speed curve, so you'll understand a little bit about how to build the motor model, at least for steady state operations. You should also have discovered how these small little motors can have some stiction in them, how to deal with that. And there's more discussion in the appendix of these slides on making digital measurements, which might be useful to read. Again, a lot of the use of the code for making digital measurements we will provide to you. One of the things that you'll do by collecting data during the testing of this motor is it'll allow you to, build up, again, you're going to be testing this little unloaded motor, varying the pulse width modulation with that H bridge, kind of going up and down, and you should be able to build and I asked for this in the lab evaluation, a little curve that shows, here's pulse width modulation level. This is the number that you can send, to the Arduino to basically control the H bridge, and then the motor shaft speed. When you measure that, right, you can measure and by the way, something to be aware of is imagine you've got that motor and you've got the shaft of the motor, and then you've got the little gear head there, and then here's omega O output, here's omega M, and since the encoder is actually on the back end of that shaft, here's where the speed is being measured. So you're actually measuring omega sub M. You're not measuring that output, which is much slower, right, by a ratio of 45 as we've measured. Okay, so the motor shaft speed is what you're measuring, not the output shaft speed. So when you're comparing to the spec that the manufacturer gives, the 9 RPM, or what is it, 90 RPM, that's what you should be thinking about, right? So check here, in this particular data, it took a value of 50, not 0, to get that motor going. So note, the motor does not start rotating, right? See here, it hasn't moved until it gets here. That shows that the motor's right, there's some stiction in there. It takes a little bit of oomph to get that thing going. So you got to get up. I've heard reports that this can go even a little higher for some motors as they get older and so on, right? They might not have, maybe, I don't know, they have some grease in there that maybe makes them work better when they're newer, or as they get older and they get stickier. But make an observation of that. That makes the motor a little bit harder to control. Works great up here when it's spinning at steady state, but when you're working around 0, turning, going backwards and going forwards, there might be that little stiction area, and these are motors that can struggle with that when you're trying to go at low speeds. The other thing I want you to think about is, can you predict performance? Now that you've measured some things about this motor, that little green point up here, right, that represents, I marked that point, that represents the value that for rated voltage, what is the rated speed. It's about 90 RPM at 4.5 volts there. By the way, the highest, the 255 up here, that corresponds to about 5 volts, which is what we're driving this, the peak voltage. So that's about 4.5 volts there. It's going about 90 RPM. That's the only thing that you know from the manufacturer about how this motor performs. So you can see at least you have a lot more information. You also have all those coefficients that you've estimated. So you have a whole torque speed curve that you can play with. Again, once you have that, then you can use that model to predict performance a little bit better for different loads, right? You can now say, well, what if I want to drive it here? What's going to be the power required? How fast is it going to go for different loads, etc. Right? So again, the torque speed curve is a much more complete specification of the electric motor than some manufacturers might provide.